Here I've got a piece of tin metal that's been etched by hydrochloric acid when I was making tin chloride, and you can see all the different grain boundaries in the metal, and they have different like angles of refraction with light, and so they shine sort of like this. Anyways, today I have a need for ultra pure tin, so I'm going to mill some of this into a fine shavings and then make some more tin chloride. All right, here we are. Got about 56 or 57 grams of tin right here. I just weighed it, and now it's time to set up the apparatus for the dissolving of the tin into solution. So I just added the tin to hydrochloric acid, and as you can see, the gases are being evolved very quickly here. I've got this on a heating mantle to help speed up the reaction, and since I'm heating it in this hydrochloric acid, obviously as you heat a liquid with a dissolved gas, the solubility of the gas quickly decreases as temperature increases. So to eliminate any hydrochloric acid vapors being released, I have placed a distillation column above here, and I'm assuming all the vapors will recondense by the time that they reach this column, and it's very likely that they will, but just in case that they don't, they'll go up here, and then they will have definite time to recondense with any water, and if anything does manage to come over, I've got a flask here. And I've also left the vacuum adapter open because as this is a reduction reaction, the tin is obviously losing electrons and hydrogen gas is being evolved, so the hydrogen gas has means to escape as well through the vacuum adapter.
Sunshine came softly through my window today. Could have tripped out easy, but I've changed my ways.
So it's been a few hours, and the grand majority of the tin is dissolved. I think this represents within the range of 2 to 5 grams of undissolved tin. So there's probably about 50 grams in total. And as you can see on the glass, maybe on the side there, there's some speckling, and those mostly are indissoluble impurities, which I will remove when I cool the solution and filter it off. And while that's cooling, I'm going to set up the cell for electrolysis. Alright, so the tin chloride here has been effectively filtered off. I have approximately 330 milliliters of solution, and I collected the undissolved matter from solution, and I tried to incinerate it, or melt it I suppose, into a single ingot. And as you can see, there is a very large blob of tin surrounded by several other metallic components. They look to be oxidized, and I'm going to assume that those are the impurities, which I was trying to remove, obviously. And so now that I have my solution, I'm about ready for electrolysis, as you can see. So coming from the power supply are my anode and cathode wires, which come to here. The anode comes and attaches into 4 separate wires, which are attached to 4 separate platinized titanium anodes, and in the center, through a piece of PVC pipe, which is wired up over here, you can see that there's a small cylindrical piece of tin which I furled into a round shape. Add this solution, although I'm going to probably use about half of it and dilute it, and I'm hoping to get to around 2,500 milliliters, so it's going to be fairly dilute. So I've just set up the electrolytic cell. It's got the required voltage and is running at 11.0 0.11 amps, which is not very much power, I might add. You can see that tin crystals are beginning to deposit on the cathode, albeit very slowly, and that's okay because the slower they deposit, the more crystalline their structure will be. So this is going to be a very lengthy process, but it is working, and as you can see, the cathodes are giving off little tiny bubbles of chlorine gas. So I'll check this in the morning and we'll look at the results. So it's been a full day, and just a few minutes ago it looks like the tin crystals fell off of the anode, and new ones are reforming. So hopefully these newer ones will have a stronger structure and be able to actually stay on the electrode. So over a few weeks, by altering the current density and the concentration of stannous chloride in solution, I was able to grow a bunch of different crystals and produce quite a few different samples, and as well as some tin which I can use in my future experiments and things like that. In fact, one of the first uses of this tin is going to require it being melted into a single billet, so I'll do that real quick. Here's the little billet. I'd imagine it's in the upwards of 99.9% pure, probably, because the tin I started with was, I think, over 95%, but the electrolysis definitely removed a lot of insoluble impurities and thus made this much more valuable little piece of metal. And I have more, but this is just a small amount of it, obviously, and I had a lot of fun doing this project. It's really fun purifying metals by making them into salts and then producing them in crystal form. I hope you enjoyed this video. Thanks for watching.